I believe that STEM is a great way for people to really express what they're passionate about, share with others, and make change in our world. And it really allows people to question new things and think outside of the box. Like a lot of things that I talked about, had no idea from the start, and I really like try to discover things that are beyond my project itself, like a lot of different things. And I know that a lot of people don't engage in these programs because they feel like they're not that capable of doing that, or they feel like it's too hard. But if you get into it and understand your passions, I'm sure that everyone has potential in achieving great things.
Hi there, this is Welcome, welcome all to this special episode of the Why to How podcast where we explore adventures in STEM. After an absolutely incredible virtual candlelight science fair a few weeks ago, it was clear that you all wanted to hear more from our Platinum and Best Project Award winners. So over the next few weeks, I'll be catching up with them all to learn more about their science fair project and the adventures they've had along the way. Today, I'm joined by Shreya Plassery, a grade 8 student from Peterborough, and our Junior Platinum Discovery Award winner at Candlelight Science Fair 2021. For her project, Unlocking the Legacy. Can mycorrhizae and spent mushroom substrate activate legacy phosphorus? I've got plenty of questions, and I asked our wonderful community for question suggestions as well. So without further delay, let's get into it. Shreya, welcome to the podcast.
Hi, thank you for having me.
Of course. Thank you for joining me. Did you want to start us off a bit by introducing yourself and briefly explaining what your project is about and also how to say the title of your project? Because I'm pretty sure I did not get that right.
Well, it's a good effort.
Thank
So my project is titled "Unlocking the Legacy: Can Mycorrhizae and Spent Mushroom Substrate Activate Legacy Phosphorus?" So I'm Shreya. I'm in grade 8 from St. Catherine Elementary School, Peterborough. Some of my hobbies are playing basketball and dancing. I've competed in the science fair for 4 years now, and uh, of course, last year and this year was virtual, and I'm grateful to win a platinum award for best junior discovery project this year. Um, and so this year I focused on phosphorus. So as you may know, phosphorus is an essential element that all living things need, and it's a major ingredient in synthetic fertilizers. However, due to over applications of phosphorus fertilizers by farmers each year, it contributes to farm runoff and water pollution. Most of the phosphorus is locked into the soil as stable compounds known as legacy phosphorus. And legacy phosphorus is not easily accessible to plants. So I tested whether activators such as arbuscular mycorrhizal fungi, which is a naturally occurring fungi in the soil, and spent mushroom substrate, which is a waste product from mushroom cultivation, if it can unlock the billions of dollars of legacy phosphorus that's hidden in our farmlands and really make that accessible to plants.
Well, yes. All right. Just a typical thing for someone so young to be interested in, which leads me perfectly into our first community question, which is, of course, where did your idea come from?
So I read an article last year from National Geographic, and it explained how essential phosphorus is, and with our current uses of phosphorus fertilizers, it's harming our environment and may not last long. So that and like a lot of the phosphorus applied becomes legacy phosphorus, which are hidden in our farmland. So I really question: are there substances that farmers could use that they could apply to their soil to help unlock that legacy phosphorus, and thereby like reduce the need for phosphorus fertilizers? So I talked to some professors, and they helped me on my experimental design, and a few websites suggested that mycorrhizae and lignin, which is an SMS, could theoretically activate phosphorus compounds. So that was really like my kickstart for my experiment.
Nice. And I imagine this isn't something you're just learning in your high school biology class, and you're definitely not learning it in math or history. So, where did you learn all about synthetic fertilizer and phosphorus activators? Where did you find all of this information you needed for this project?
Well, there were many helpful websites and platforms that explain how farmers are overusing synthetic fertilizers and it's harming like the plants themselves and animals, and it's really like a growing concern for global food security. Um, and yeah, like there's a lot of websites, and it explained how like not only phosphorus but other macronutrients like nitrogen and potassium is also limited. But like, but I chose phosphorus because that phosphorus resource from rocks is limited, and according to studies, it may not last long. Um, yeah, but I really would think of a question, and sometimes this would even be like in my sleep or like, whenever. And I would just like jot that down on my notebook. And then when I wake up, I'd have like a notebook of questions and just research everything. And, that it could require heavy research, but I really enjoy doing
Google is your friend, is basically what you're telling me. Yeah, you can learn
that.
everything online. um, and so, who did you turn to for support throughout this project? Did you have mentors? Did you have professors? Who helped you along the way?
Yeah, so not only Google, I had a lot of professors and a teacher. Well, a teacher from my school, actually, Miss McInnes, she has guided me throughout all my years during my science journey. She's like giving feedback and proofread my work, and always got me wondering like, why is this happening, or like, why do you believe that this is the reason for this result, and like how it's so important to justify your answer. And I also had a mentor, Dr. Piper, who had helped me this year and has also proofread my work and taught me about things that I didn't even know before, like especially all those statistical stuff. Like, wow, I had so much fun learning that. And like Miss McInnes has also suggested or like helped me reach out to professors from the University of Guelph and the University of Trent, and they have also shared their expertise and their like valuable insight. And this was actually my first time talking to professors, and wow, like I'm so happy that I was able to do that because like at first I kind of thought they why would they want to help a kid's science fair project? Like I thought they won't have time for that. So I I'm so happy that I got to do that, and like they were so eager and like they were so open to share their knowledge. So that would actually be a tip to reach out to as many mentors and like probably ones in your same field that you're working in because they're like always willing to help you.
Yeah, and it's definitely good to reach out to a lot of people, a lot of diverse range of people as well, because everyone can provide such unique advice and feedback. And I know I discussed with Hart just recently just how important that feedback loop is to refining your project and just making it something from good to great. And it's all about obtaining feedback from as many people as possible, just to be sure that everyone's understanding is on the same level as yours, because it is a wonderful project and there's a lot going into it. So you just want to make sure that the outcomes you get and the results you get are understood by people.
Yes, exactly.
And so, what did you discover? Well, after all of this work, what was the result?
I found that plants with mycorrhizal inoculation had a higher shoot length, leaf size, a number of flowers, and fresh and dry weights than other groups. And like the other groups were controls, so like without activators added, with spent mushroom substrate and a combination of mycorrhizae and spent mushroom substrate. And also, at the end of my experiment, I also did a leaf nutrient analysis on plants in soil with very low phosphorus, and the results showed that the plants had sufficient levels of phosphorus, which means that the plants were probably able to access the legacy phosphorus. that was like really cool results.
Yeah, I can imagine. So basically, you're trying to figure out how to access something that's already in the soil, so that
Yeah,
farmers don't have to add it on top. Um, which, I guess, why is this important to us? Like, do you want to explain a little bit more, a bit more
yeah,
detail than farmers don't have to use fertilizer?
yeah. Yeah. Well, my project is so important because phosphorus resources will run out soon, and it's important that we make sure that it doesn't run out for our future generations. So for my project, I actually had one soil with very low phosphorus and the other soil with medium phosphorus, and they performed almost equally as well. So that really means that most of the time, farmers are adding excessive mineral phosphates, which the plants do not need. So to not harm our aquatic plants and animals, and to ensure global food security, I feel like we need to use efficient pea activators like mycorrhizae to really help access the billions of dollars of legacy pea that's hidden in farmlands.
Wonderful, amazing. Yeah, what fascinating work. Um, and now, ex- on top of just even pronouncing the words, what were some of the other challenges you had while doing this project?
That's a good question. There were definitely a lot of challenges. I I I don't think there has been another experiment that tested SMS if SMS can activate legacy P. So I wasn't really sure what concentration would be enough or like not enough for the plants. So I originally had 25% SMS, but then professor suggested that I should use 1 to 2% SMS, similar to like manure usage. But so I had to like restart my experiment, but I used 10% SMS to see like a visible effect of it. But like unfortunately it was too high the concentration. So that was kind of like an error I did. But I feel like it's good to have errors because you know what to do for next year. And yes, and I had like I first did the experiment and I used potassium chloride. But however, like later I like researched and I found that chlorine in potassium chloride could potentially harm the mycorrhizal fungi. So I didn't really want to take that risk. So I restarted my experiment with potassium sulfate since it's safer and it's a micronutrient for plants. Also, sulfur is a micronutrient. So I think I had to restart my experiment like 2 times, but it's a whole part of the process of making sure I do my project as perfectly as I can. Um, yeah, and like originally, I'm thinking of other times. Originally, my I had the idea for my project was to do woodland and farmland soil, but I changed it to two farmland soils because they would most likely have legacy P because of like phosphorus fertilization during the previous years. So it was actually like during winter time, like everything was during winter time, so it was a challenge to go there and dig up all the snow or all the soil from like under the snow because it's like a the snow's kind of like a blanket on the soil, so it's hard to do that. But that was just a minor challenge though. Um, but yeah, I think that would be it. I there are a few challenges with COVID, like it's hard going to the farms and asking for samples. Like it's hard to get a lot of info in person, but like the farm, like those there at the farms and the um like the SMS farms and the soil farms, they were like all very welcoming. So that was really nice.
That's nice to hear. Yeah. And I can imagine, yeah, definitely some challenges along the way. So set the scene for us then. Have you just got like a second bedroom just full of plants and soil everywhere? Like where are
Yeah,
you doing this project?
I originally had like a room just for art because I love art and I do a lot of painting. And then I had to take all the paint brushes and everything out of the room, and I dedicated that whole basement place for my science fair. I mean, I'm not disappointed or anything. Like I can do art later. Yeah.
Yeah, so you're a bit of a green thumb then?
Yeah.
Yeah. Um, so then, can you describe for us what you felt when you received that lab report and realized what it meant for your experiment? That lab report that just said this project is a success. What did it feel like when you opened up that letter?
Oh. I actually had like two lab reports. I did one at the start of my experiment. Um, yeah, I did like a soil test at the start of my experiment, and at first I was like, oh, why do my soils have very low and medium phosphorus? I thought there's going to be more phosphorus in my soils, but I realized that there's probably a lot of legacy phosphorus because the soil tests are not able to really calculate the legacy phosphorus, only like the available phosphorus. So it was kind of like a blessing in disguise that I got my soils close to low levels of phosphorus, because then I can actually see if my activators did unlock the legacy phosphorus and help my plants with other nutrients. So yeah, so that was my like first lab report, and then my I did like a leaf nutrient analysis at the end of my experiment, and that was like a success. I was so happy when I saw that. The plants that had very low phosphorus had sufficient levels of phosphorus. So that means that it most likely unlocked the legacy phosphorus, which is a success.
Yeah, it's such a great feeling, right? When you put in all of this work, all of this effort, you've pulled down all your artwork, you've put in plants all through your basement, your parents are sick of you talking about phosphorus at the dinner table, and then all of a sudden you open up this envelope and you see it all worked. What a great
Yeah,
feeling.
I know. It's like almost 6 months of work, and I'm so happy, and I got great results.
I bet, yeah. So then what happens next? Where do you go from here? Start a farm?
Talking about great results, I well, actually, the 10 I said earlier that the 10% SMS was a too high of a concentration. So like since the 10% SMS like had a negative effect on plant growth, I'm thinking that in the future I will do like 1 to 2% SMS, like my professor suggested. I should have listened to them.
They're kind of
Uh,
smart, right? Yeah.
um, but yeah, I'll probably use 1 to 2% SMS in the future, and I could even test other P activators like zeolite and biochar, and there's like a lot of P activators, so I could test those, and I could test if mycorrhizae could work it with non-leguminous plants as well, and I could even test if P activators could be tested in organic versus conventional soil to see if really like comparable results are achieved.
hmm So basically, you're not sick of phosphorus yet, is what you're saying.
No, not no.
Not yet. Um, and do you have plans to one day plant a full crop and see if the test works on a larger scale? Like where does that fit into your life plan?
Well, hopefully I can tell farmers to like reduce the use of mineral phosphates and use like effective P activators on their crops. And even for me, I could use effective P activators for my backyard plants. You know,
You
I
haven't
did
started
like,
doing that yet. You haven't started digging up your mum's garden yet.
and I will be soon.
Yeah,
Yeah,
nice. Well, let us know how that goes. Yeah,
definitely.
and so being able to tell a good story is so important to being able to express such a complicated issue. And I mean, when you use such big jargon such as, um, spent mushroom substrate (SMS) and mycorrhizae and phosphorus and legacy phosphorus, most people don't understand what these. I mean, I certainly don't. I didn't know anything about it before I read your project. Um, how do you communicate what you're so obviously passionate about to friends, to family, to curious members of the public, to your farmers that you're getting your soil from? How do you share with them what it is you're doing without just confusing them and thinking you're some weird phosphorus child?
Well, I can definitely say that communicating your project is really important. Sometimes like people with incredible project would explain it to me with like scientific jargons, and I'd be like, "I'm sorry, please, what was that again?" But I would like to. I usually explain it kind of depending on what my audience is. With judges, I usually use more scientific jargons um, and because like they have a lot of expertise, and I want to make them feel like I did research. But to my family and friends and farmers, I try to say it in like an understandable way and relate it to other things that everyone knows about. Yeah, so I just always try to think to myself, they don't know anything about my project, so how would I kind of say it to 2019 Shreya, you know?
I'm sure 2019 Shreya was pretty smart as well, and still loved a bit of Legacy P.
Yeah, but she didn't know anything about this project.
Didn't know anything. Yeah. um, and so then talking about science fair and science fair projects in particular, what is your favorite part about science fair? Why did you get involved in science fairs all those years ago?
Well, my favorite well, the reason that I joined science fair because I really like the concept of sharing what you're passionate about to others and kind of like talking about an idea you're passionate about and using like help with others and making that into a project, and I feel like that's super cool. And for my experiment this year, I would say probably growing the plants was really fun. I really like to see if my results kind of aligned with what I thought it would be. And you might have heard me in like the meet the winners, but I said I was like super excited to wake up like early in the morning and like rush to my basement and see how my plants are growing. Yeah, but just like overall, like in the fair, I would probably say my favorite part was working as a squad. And this is something that I haven't done before. So going to Canada Wide with winners, like they're all winners, where as a whole squad, it's amazing. And we had so many Zoom meetings, and we had such an um like amazing mentors and and Miss Emery who organized it all. She kept on sending us emails. She was so like hyped up about it, and we were also hyped up about it. And we had so many Zoom meetings where we would do interactive activities. Like in the science fair website, there's like the escape maze and the I forget what it's called, the quit where you'd like be in like some place in the world and you have to try to guess where you are,
Yeah,
depending
guess so.
on the
Yeah.
yeah. We had so much fun doing that, like our whole squad. And yeah, I remember we had like a Zoom meeting together during like the award ceremony, and we would like cheer for each other and we'd be like so excited when like one person from our squad would win something. Feel like it was just so wholesome and fantastic. Yeah.
Wholesome's such a good word for it. Yeah, the
Yeah.
science fair community is wholesome. It's so great being able to meet other people that have a passion for something, even if it's not legacy phosphorus. But just like knowing that there's other people like you out there that have dedicated all of their spare time over the last 12 months to do something super cool, and everyone's so passionate about it, and they just want to share it all with you. Um,
Yeah,
yeah, like these.
definitely. Like meeting like-minded people and then viewing their projects. Like I had so much fun like exploring what they did. That was yeah, that was fun.
So besides all of that, why should why should high school students across the country do science fair projects on top of everything else in a very busy teenager's life? How do you also wake up every morning and run to the basement to plant your plants?
Well, yeah, I definitely would say it's kind of hard to manage school and science fair at the same time. But the main thing is to really use your time wisely. Like when you're like committed and passionate about something, I would say at least spend 10 minutes each day on your project instead of like trying to cram everything in on like the last day or last week. Just like spend at least 10 minutes each day. Um, but I do feel like it was a bit easier to find time to research for my project this year, especially since I don't have that many extracurriculars like badminton and basketball. But I do feel like if there wasn't COVID and when I go to high school next year, there would be at least some time during the day that I can use for the science fair instead of going on like social media and watching TV and like watching Netflix. Yeah. I wouldn't say don't enjoy yourselves, but just know like how you use your time is what your output's gonna be.
Yeah, and choose something that interests you, so that it's not like you're having to give up something you enjoy to go do this boring science fair project. You are not watching TV, which might be something you enjoy, to go do the super cool thing like check how big your leaves are on your plants in your basement.
Yeah, definitely. I feel like if you do something that you're passionate about, you'd want to spend a lot of time of your day to do that.
And I can tell that you're passionate about it because, I mean, you mentioned phosphorus in every sentence, but also you mentioned that you have a notebook next to your
Oh
bed to write
yeah.
down questions that you have overnight. Like, like, tell me the truth there. How many times have you dreamt about your science fair project, do you think?
I you know the last week before my like judging, I think I dreamt about it like every night. I think so. Yeah.
What a cool kid. I love it. Amazing. Um, so then, community question for you. What do you dream of being when you're older? Talking about dreaming.
Hmm. To be honest, it changes often. Like I,
Yeah.
I wanted to be like a unicorn and like ride up in the clouds when I was like 7, and then I wanted to be like a teacher, and then I wanted to be like a pediatrician. But really, right now, I from like my past um, experiences during the science fair, and especially this year, I really want to focus on science in the future. Um, I don't know exactly what, but something that includes science and what I'm passionate about.
I mean, don't stress about it. You got plenty of time to decide what you want to do with your life. I mean, I am much, much older than you, and I'm still trying to figure it out.
Don't
So,
worry.
just I love them getting advice from you now. Yeah, don't worry about it. You're fine. Just stay curious and keep your interests because you never know how you end up in it. I mean, I wasn't a science fair kid. Australia doesn't really have science fairs, but we did have a science fair, a science project program in year 12. And I was like, yeah, I love science, I love STEM. And then I went and did accounting. What? So boring. Why would I do that? And now here I am, all these years later, still involved in science. Um,
I can
it's weird.
definitely say that I wasn't the biggest fan of science before. Also, like I I like did the science fair. I said like I did for 4 years, and like the first 3 years, I didn't get any award or anything, but that didn't stop me from like trying harder each year. Like even though I didn't win, I didn't lose interest in it. So it kind of like grew each year. So
Mm. It's hard to like science when you want to be a unicorn, you know?
yeah.
You can't, it's hard to do both at once.
Well, that was when I was like 7.
Yeah, so what's that, like 4 years ago? Yeah. Okay, so big question for you. Why is STEM important?
That's an important question. I believe that STEM is a great way for people to really express what they're passionate about, share with others, and make change in our world. And it really allows people to question new things and think outside of the box. Like a lot of things that I talked about, had no idea from the start, and I really like try to discover things that are beyond my project itself, like a lot of different things. And I know that a lot of people don't engage in these programs because they feel like they're not that capable of doing that, or they feel like it's too hard. But if you get into it and understand your passions, I'm sure that everyone has potential in achieving great things.
Yeah, just remember, 2019 Australia knew nothing. And now, 2021, she's winning an
Yeah.
award.
Wow. Such an amazing story.
Yeah, so inspirational.
Inspirational, yeah.
All righty, last question for you. I mean, let's go a few sub questions, but last question for you. Do you have any advice for people looking to get involved in science fair coming up for the next year? How do they choose what to focus on? How do you stay motivated?
Well, I would definitely say if you have an idea, and even if it's a small idea, you should research it and develop questions that you want to answer. If you're not sure what to focus on, I would say definitely research a ton. Like there are so many valuable websites and books. Yeah, so many valuable websites. Um, that that and that's how I got my idea. So like don't be afraid to really share that with those who can help you make that into something bigger. So I always encourage myself to really work hard. Really I need to work hard to make change in this world. So that could be by like setting times each day or maybe making like to-do lists. I know a lot of people don't do that now, but I feel like to-do lists are awesome to, use your time wisely and really feel a sense of fulfillment.
I love that we come a full circle, and your answer is basically just Google it. Pretty sure that's the first piece of advice you gave. Yeah.
Yeah.
Well, Shreya, this has been absolutely fantastic. What a truly incredible story you have. What you've had such fun adventures along the way. I've got to say, it's adventures in STEM, and what a fantastic project that you put together. I mean, congratulations on winning your award. It's truly an amazing achievement for you.
Thank you so much. I had a great time talking about my story, and you're such an amazing host.
Oh, thanks. Now I'm blushing. And if you haven't yet, please do go check out Shreya's project on Project Board. I'll be sure to include the link in the show notes to this podcast episode. Or if you're on YouTube watching us, it'll also be in the description below. Add some comments, let her know how amazing her project is. Feel free to ask any questions. She'll jump back on and answer them for you. And we'll have another amazing award winner for you in the next episode. What a fun way to get in touch and discuss some incredible adventures in STEM from our best of Canada-wide Science Fair 2021. So Shreya, thank you so very much for joining us.
Thank you for having
I'm
me.
excited to see where you take your project next year.
Yeah, for sure.
Okay, bye all.